The triangle of velocities concerns heading and TAS, wind direction and speed, and track and ground speed. Let's set on a wind velocity of 210 30 knots using the low speed side. Rotate the inner scale so that 210 appears under the true heading index. Position, say, the 130 speed arc underneath the centre dot and count down 30 knots below the centre dot to where the 100 speed arc crosses the centre line and draw across. This shows wind from 210 at 30 knots, drawn down. Let's try an example. Your heading is 116 degrees true, TAS 120 knots, wind velocity 260 40 knots. What is the track true and ground speed? First of all, decide which side to use. Since TAS is 120 knots, use the low speed side. Rotate the inner scale so that 260 appears under the true heading index. Then draw on the wind down. Position TAS of 120 underneath the centre dot. With the wind drawn on, now rotate the inner scale so that the given heading of 116 appears under the true heading index. Under the wind cross, read off 9 degrees port drift and ground speed of 154 knots. Heading is 116. You are blown from heading to track. With 9 degrees of port drift, you are blown 9 degrees port to a track of 107. Let's try another example. Heading is 227 degrees true, TAS 420 knots, track 234 degrees true. Ground speed is 385 knots. What is the wind velocity? First of all, decide which wind side to use. Since TAS is 420 knots, use the high speed wind side. Move the slide to position 420 knots TAS underneath the centre dot. Now put the heading on by rotating the inner scale until 227 is under the true heading index. Track is 234, which is 7 degrees starboard. Draw a line over the 7-degree starboard drift line. Find the given ground speed of 385 knots and draw a line along the 385 speed arc through the 7-degree starboard drift line. Rotate the inner scale until the cross is over the centre line below the centre dot. You may now read the wind direction of 177 degrees true under the true heading index. The wind speed in this case is not easy to count out. To make it easier, move the slide to say 400 knots. This does not affect the reading. 10, 20, 30, 40, 50, 60 knots. $177, 60 knots. Another example. TAS 170 knots, wind velocity 083.35, required track 036 degrees true. What is heading true and ground speed? This is the practical example that you use in everyday flight. TAS is 170 knots, so use the low speed side. Move the slide so that 170 knots appears underneath the central dot. Draw the wind on first by rotating the inner scale so that 083 appears under the true heading index. Count down 35 knots from the central dot. 10, 20, 30, 40, 35, and draw across. Rotate the inner scale to a required track of 036. Drift is 10 degrees port. Now we need to drift balance. Rotate the required track of 036 to 10 degrees port. Check where the wind cross is. It shows 9 degrees port. Rotate the required track of 036 to 9 degrees port. Check the wind cross again. Both readings of drift are the same, 9 degrees in this case, so drift balancing is complete. We can now read our heading of 045 under the true heading index, and a ground speed under the wind cross of 140, 142, 144 knots.